All right, hey everyone, thanks for coming out this morning. For the talk, we're talking about the origins of insecurity, which is sort of like why we're all here. If we had a perfectly secure world, insecurity, we probably wouldn't be having this conference. So if we roll back sort of the regular day-to-day tasks, where does all this sort of mess come from? And I assume I got this right, James, but I assume the hashtag is BlastCon or something close to it. And here's my info if you're so inclined. Okay, also, these slides right now are on speaker deck. If you saw what LinkedIn is doing with their system, I decided to switch over and convert over. So anyway, these slides are up now. And a little bit about me and my background. My title right now is VP of Engineering. Security is not my primary gig. It's always been something I view as, if you're doing security well, typically the rest of your stack is also working well. I don't know too many companies who have great security systems, but like terrible the rest of the company. So it's really sort of like an offshoot of like excellence in general. My company is called Icon Web. I live in Tokyo. They're in Moscow. I'm an American, make your own jokes. What they do is online advertising infrastructure. So one of our customers is weather.com. Instead of putting Google's tags on, or Microsoft's tags on, or Adobe's tags on, you can put weather.com's tags on your site and get weather advertising or whatnot, or the reverse too. Because waiting for Google or whoever, they're perfectly fine systems, but as it becomes a more and more important part of a company's revenue stream, waiting for them to cut checks isn't really a business model. You're not really in control. So anyway, these guys, we produce like 30 or 40 sort of real-time advertising exchanges, and a lot of volume. Anyway, how many people here deem themselves sort of like pure security, like that's your primary job? Cool, so maybe about half or more. Okay, so here's your goal for next time. Please bring one of your friends from development, business, operations, whatever, even product if you're so inclined. Not only does that make the conference a lot more interesting, economics of a conference change when it's twice as many people, but we got to get more people involved in what we do. Okay, so Keynote, that was an interesting last year. For people that were here last year, that's been a kind of exciting year, right? I mean, it's interesting because the trends go in waves. About a year ago, the big rage was password dumps, and now you just open up, newspaper and you're seeing some new revelation on spying or whatnot. So to sort of start out some of that, I'm going to talk a little bit about a lot of stuff you might hear in the news on cryptography, and sort of relate that to our day-to-day jobs and how things come about. So a lot of noise is flying around here on cryptography, SSL, all of this stuff. There's a lot of noise, very little context on how it might actually apply to you or your business. You really need to take into account your threat model. One size definitely does not fit all. And the good news is about our industry, and you might have seen, you might get a little depressed over the revelations or the constant grind of things. But at the end of the day, what we do is a wild success. I pulled these numbers from Forrester. $250 billion was transacted in the United States on e-commerce. If security was a complete disaster, I'm pretty sure that number would be smaller. So that's really a huge success, like everyone here, in spite of all the headlines and noise and breaches and stuff like that. Honestly, it's an overwhelming success. 10% of all retail now is done online, which is a gargantuan number. That said, and also with revelations coming out, so far I have not seen a single thing that says the mathematics is broken. I just haven't seen anything about it saying that fundamentally the systems we're using are broken. So much so, this is a great article. It's not based on leaks. This is based on sort of journalism. It's really about how the NSA actually does their job. And too long don't read is that's really hard and really expensive. It's much easier buying off people and access. Like, this article didn't say it up front, but it really says, like, the math's really tough. Like, breaking actual cryptography is actually really hard. It's so much easier, spending some sysadmin, $300 to get access to something. Worth reading anyway. Actually, the cryptography part is actually so successful that I actually don't know of any breach that was actually based on breaking mathematics, brute forcing AES keys, brute forcing SSL keys. If you know an example, I'd love to know about it. Everything I've seen is attacking data at rest or bypassing the mathematics altogether. That's actually good news. And if you're sort of thinking like, I think that's kind of bullshit, because what about these problems? We've had a couple of random number generator problems. We've had a bunch of certificate authority problems. What's going on there? So I'm just going to digress a little bit. Hopefully you get this meme reference. Excellent. And you'll see it even more apropos later. And I'm going to use these examples to just sort of discuss what problems we aren't really addressing very well. So the first thing is this guy, which is sort of the default secure random number generator. And August, there's this little thing like, hey, Bitcoin, something's a little funny, it was sort of vanishing. And lo and behold, stolen. I think it was on the order of $6,000 or so, which is still fairly small. A little surprising how small it is. Now, a few days later came out this wonderful euphemism, secure random thoughts. Some thoughts by basically, it said, it's completely broken, it's seeding, you're not getting actual random numbers. And here's a patch. The original post is there. I'm not an expert in Android source code tree. Maybe someone is that could help me out. I actually can't find the commit that fixes this. I can't find a change. I can't find a bug report. I don't see any empirical testing that would actually solve this. Random numbers have some pretty nice properties that you can actually just do experimental testing on and see if they're broken. Not terribly complicated. No fix, no sort of test. Here's how we're going to prevent it again. Sort of, here's a patch, go nuts. But what's interesting about this is this didn't just affect one version. It's been in every version of Android since it started, which is pretty substantial, actually. So I sort of did some exploring on this. I thought it was a little weird, and I came across this tweet, which definitely snarky. Someone wasn't too happy about what happened, fair enough. But it provided a link to the original check-in of some of the code. And I sort of took a look. The original check-in was in 2006. And unfortunately, it's too small, but you can see it. It goes, hey, thanks for the commit. Can you check that it worked? Great, thanks. Oh yeah, no tests. Test came in at least 3 months later. So before we blame poor Yuri, if we look at sort of the whole Java infrastructure, is it based on known good principles? Seems to be. Is there respect for it? I couldn't find it. Java's a little old, so this might have been on the web at one time, but I can't find it anymore. Open source reference implementation, no. Test vectors, no. Are you actually forced to use it? And the answer is kind of. Java just doesn't let you plug in secure random instances. It's this whole API to make it proven. Code, no test, no empirical test, and honestly, no review of any of it for the last 5 years. So, not so good. And furthermore, there's something else, sort of like the buried lead was in the sentence. Oh yeah, and the other random number generator, we screwed that up too. And you can go look on that later. Someone did some research on what exactly this is. And there's still more details. Someone actually did notice it was broken in March of 2000, this year. Someone else did some more details. But honestly, very little research or details coming from, I would expect, Google or any other like, oh yeah, we patched everything's cool. So I sort of view this as like a real interesting case in like how everything went wrong. You know, specification, implementation, QA, review. None of this is terribly hard. None of it happened. So comparing it to the other thing that's definitely in the news, this came out first. You know, NSG is getting a lot of crap, and they probably have demands we can't even imagine. Standards is money. So the stuff these guys have to put up with is pretty shocking. It's a human organization, and certainly has human failings. And yes, we got one of them. This random number generator is one of 3 specified. Got published. However, you can do a search on this. There's nothing terribly new about what I'm saying here. Within 6 months, people were like, "This is wrong. Like, this just doesn't." Not only is it suspected in the back door, it's also really slow. Like, there's no reason you'd ever want to use this generator. And not only that, there's 3 of them in the spec, so you don't even have to use it. So something got corrupted. We'll probably never know exactly what happened, but it sort of went awry. However, it is a standard. When we look at it, is it sort of based on known good things? Yes. Is it open and fully specified? Yes. Do we got test vectors? Yes. Do you have to actually use it? No. There's nothing in FIPS requirements saying you have to either implement this or use it. There's 2 others you can use that are just fine. So even though it's a broken standard, and we know it's a broken standard, it's very clear and you can very specifically understand it's broken, as opposed to the one before, it isn't really quite clear what's going on. So, not only that, the standard got approved by ISO and some European agencies as well. So it's bad. It's a bad standard, sure. It's certainly not the first, and certainly won't be the last. However, and this is where I think our industry needs to come into play more, standards don't even suspend common sense, right? So this came out last week. I don't know who these guys are. I apologize if I'm picking on you. Press release, hey, we removed this broken thing. Well, we knew it was broken, right? We knew it was broken in 2007. You didn't have to wait for Mr. Snowden to release something to know you should have pulled it. This is stuff we could have made decisions on. I'm pretty sure this is included. So, if something is broken into, you can just sort of subvert the library to use, random number generator number 3. No one would actually pick it, but it's there, use it. These guys can remove it at any time. For them to do a press release saying they removed something that was broken is a little weird. And good standards don't do any good if we don't implement them, right? So, TLS 1.2, first, I never noticed it before. The author's company is RTFM Incorporated, which I think is somewhat awesome. I never noticed it before. But the other thing that's shocking is this was approved. Approvals take a long time. It was approved in 2008. That's a long time. And you can't blame the NSA for making our entire industry not implemented. Not all browsers support TLS 1.2. And this GCM mode, which has a whole bunch of nice properties which prevent a lot of problems, crime, abuse, and all this other stuff. No browser supports it. So after 5-6 years, it's a bit of a mystery that crypto code certainly would be a desirable thing to work on for a certain subset of people, yet no one did. So that's just sort of like our industry decided not to do something that we know would fix things. And it's in dev branch and Chrome, so coming out soon. But right now, nothing. But to be fair to everyone, a lot of our security stuff we're doing, honestly, has never been done before. Here in 1995, we set up the CA system. There's nothing like, oh yeah, that's how you do it. That's never been done before. No one knows actually how to do this, right? So, old standards are going to need augmentation and updates, and certainly those other things, but there's new things here which certainly sort of simplify or reduce risk. I don't think Zane's talking about this is going to be pruning, not today. Okay. basically, you only need like half a dozen really CA authorities, and the rest you can just eliminate, which saves a lot of problems. CertificateTransparency.org, it's Google's sort of project, but it's becoming a standard. Basically implements a worldwide monitoring system of what you see for certificates. So if there's a man in the middle, or if CA is corrupted, you're able to detect this in real time. Really interesting stuff. I suggest you please read about it. It's really interesting stuff. So that's cryptography. Right? What about everything else? And this next slide is really ugly. I didn't have time to hire a designer, so we look at everything else. I told you. Right? We look at everything else we do. And this is why I sort of view like organizational chart for like tech. You got app security, stuff we write. Tech ops, stuff you didn't write. Endpoint security, stuff we use. And we do lots of really interesting stuff. I'm going to offend some people here by not including some of the positive stuff we do, including research. We do all sorts of great stuff. You know, detection, monitoring, identity management is just a hard problem because it involves people. You know, design, architecture. If you're lucky, you got some engineers and you're actually building stuff. But for reactive tasks, things are oddly sort of boring. Internal tech IT stuff. What's the main security task besides identity management? Configuration management and patching stuff. Typically C-based applications. Right? I mean, like you're updating, Windows. It's your 5 or 6 dozen applications. It's keeping things current, and certainly making sure the configuration of those machines are up to date and consistent. Tech ops. Besides all the positive stuff, when it comes to reactive stuff, it's patch, patch, patch. C infrastructure, C infrastructure, C infrastructure, C infrastructure, and handling configuration management. For development, a little more diverse, with a ton of input validation problems, none of which are technically hard. None. Configuration problems. Logical problems are a little more interesting. Like those are like real bugs, real logical design issues, data handling issues, password storage, all this other stuff, and certainly language-specific warts and problems. But even those language-specific problems, 99% of them, okay, they don't have the number 99%, a lot of them are basically patching the language, which is typically in C2, right? If you look at the CVEs at CERT, and look at the high-profile ones, it's like C, language. You don't see too many high vulnerabilities of the language libraries updated. You see PHP updated, you don't see PHP module updated that much. The really severe ones. PHP is a little different exceptions. It seems like remote code execution happens constantly. But in general, Java libraries, the Java core that's getting patched, Java C libraries getting linked in. So, for the reactive summary, these are the hot things. Patching, configuration management, broken applications, deploying applications, and dealing with C-based infrastructure. So, let's sort of look at this a little bit. This came out 3 weeks ago. Securing more by patching less. And there's absolutely nothing wrong with this sort of guideline. It's guys saying, hey, I'm overwhelmed by trying to keep everything up to date. Let's just focus on things that really matter. And this was part of Dan Guido and Trail of Bits and the Exploit Intelligence project. And okay, this is number 99%. I made it up, but there actually is a real number if you go look at it. It's extremely high, 95%. And you just patch 5 or 6 different things. 99% of the exploits are blocked. That's an incredible number. And so this guy is saying, hey, if you just focus on these, you're going to secure more stuff. I will also point out this website has a problem doing HTML and UTF-8 coding by the little blurb over there. It's like attention to detail. Anyway, so if you just patch these 4 things, you just solve an enormous amount of problems. The problem is, this is actually really hard for a lot of organizations to do. prioritization is important if you can't actually patch everything. If you could patch everything in an hour and across an entire org in like 10 minutes, you'd do it, right? You wouldn't need to even worry about, is it a severe vulnerability, is it not a severe vulnerability? Just do it. But updating even 4 systems is really challenging for a lot of organizations. That's kind of weird. Right? That's sort of the key right there. What can we learn from the hardest apps to deploy? I'm going to use Google as a positive and negative example. So Google Chrome, positive example, which honestly has actually changed how a lot of software applications are developed. We've seen a lot of people adopting this model. This is a lovely graph from Ars Technica showing adoption rates. And what's great is, the difference between these colored bands is about 6 weeks. If you draw a vertical line through them, you're only really touching 2 colors. It's really quite amazing. And if you look at the scale, like, I don't know, who are these guys? What are these guys? What's going on with them? If I had a consumer website and I saw these guys using an old version of Chrome, I'd be like, what? What's wrong with their system? Something is seriously broken with it. Anyway, so that's like a beautiful, beautiful graph, and I talk about all this stuff. And notice it's not deployed 100%, it's rolled out gently. Bad release happens, they can roll back, do something else. Let's look at the painful negative example. Not as pretty. If you draw a vertical line, you're touching like 3 or 4 versions. And really it's only this good, the adoption rates, because people just throw out their phone and buy new ones. I mean, that's how most of the adoption is actually occurring here. Carriers just aren't pushing out stuff. This is like a huge problem for Google. These releases are 6 months apart, 3 different versions active at any time, not in control of the release process, slow adoption. It's a disaster for them. So they know that. I assume they've looked at the success of Chrome. And what they're doing is they're chopping away the OS. OS is just going to be for hardware. All the apps, including keyboard, are now going to be auto-updated from their store. Clever. But the point is they're able to release faster and push security fixes independent of the carrier. Apple too. Apple doesn't have a problem getting people to adopt their OS because they've done a pretty nice job of marketing, building demand. It's kind of a clever way of doing it. But you're now in iOS 7, you're saying like, oh yeah, all the apps are auto-updated. And I look at some friends' phones and older ones, and you see the number of apps updated, like 100. So they just don't do it. They don't plug in their phone and then push the button. So they're moving to auto-update. Desktop's lagging behind. I didn't check out, I didn't dare update to Maverick before this presentation. I can do it afterwards. But you're seeing them move in that direction there too. WordPress just came out this last week, automatic background updates. A lot of people are going to lose livelihood on that, because I'm sure WordPress has developed quite a security maintenance problem. That's actually, for a web, WordPress is a funny thing. It's an application, a service. For it to be having auto-update is actually really interesting. For a website to auto-update itself, another thing. That's actually a pretty good innovation. I just saw this the other day. And this is actually following the thread here, is you install FreeBSD, the first time it boots up, it pulls down all the security stuff. The thread's like, well, don't most people do that? And they're like, yeah, but not everyone does it. And we want to eliminate that source of failure. It's these types of innovations that are really going to change and improve security for a lot of people, and save time for all of them. So you can release faster, earlier, safely. These are hard apps to deploy, right? Somehow they're pulling it off. You don't see the problem with Chrome like, oh, I downloaded this, crashed, and breaks. It's a really complicated C++ application, and they're able to push out to hundreds of millions of people. It can be done. You can deploy quickly, even in complicated applications. But how do we apply this to the desktop? And for people here who are more operationally focused, this is a challenge. How can we make it easier on the desktop? I don't believe that with all the containerization technology, VMs, VirtualBox, Docker, fake stuff, that you can't do something to to make it easy to deploy. As an RSA February, didn't see anyone working about how can we update Windows. It's a real problem for a lot of companies, so they don't do it. How can we detect if we do push an update to our desktops that it's working? What's your feedback mechanism? I don't have the answer to this. This isn't my specialty, but I believe it can be done if we decide to actually look at it. Okay. And really the conclusion is, how can we make patching and deployment easiest for the dumbest users? Right now it's still a science project. And if you run a map shop, like trying to figure out how to manage that for the enterprise, it's actually really hard. Briefly on configuration management. You can go on the web and how should I configure Apache? You'll see the biggest random assortment of stuff, especially after forward secrecy and all this other stuff has come out. It's turned into this big issue. It's somewhat invisible for most users. They configure their website once, they're good. They haven't really thought about it in years. It doesn't have to be a science project. This is the dumbest configuration you can possibly do. It's still an SSL lab to getting an A. You can memorize that. I like that. Could it be a lot better because of compatibility problems? Absolutely. But it doesn't have to be so complicated. However, if you're really smart and figure out a beautiful configuration, being smart won't save you. This happened to me actually a few weeks ago. Configured everything. I did an OS update, wiped out my binary version of my web server, and my SSL cipher speed dramatically changed. And I only noticed it sort of by accident. Silent changes happen. I've been at companies that were doing router changes. Poof, certain parts of the site don't have SSL anymore. They're silent. I don't know. So, and SSL is actually the easy part. Even Apache and Nginx is only 5 configuration variables you can do. And if you look at the config of SSH, it's a little different story. Any VPN, it's pages and pages and pages of configuration. DNS, not going to touch it. Too scary. And it's easier and easier for anyone to put a server on the internet. So our challenge here is, how can we make it safe to configure a server and keep it secure easily? If you start Apache Nginx, you configured SSL v2 for some of those already. You just left it in there 10 years ago. There's no warning, nothing, silent. How can we make it easier for people to detect problems? So this is actually probably a really easy patch to put in. I don't know if it'll ever be accepted, but it's little things like that just warn people anyway. Right now there's no warning. Can we do this for application development? Ruby on Rails breakman, static analysis on commit. You commit something that is broken security-wise, you get an email. Fix it, you get another email saying thanks. I don't know anything about Ruby on Rails, but I do know if I started and I have this running, I'm not going to make certain types of mistakes. That type of sort of hand-holding is really important for us going forward. And I'm pretty sure if we can do a static analysis for Ruby, pretty sure we can write one for Apache config or your SSH config, warning the user of what's going on. Just don't see those things right now. Cryptographic primitives, this is fresh off as making the slide this morning. Unfortunately, I cut and paste the API of PHP's script module, and interestingly enough, there's some issue going on with Google and safe browsing. But either way, raw cryptographic primitives, great for research. Developers really just don't need to be using them. It's just not an appropriate level for business. All right? So PHP is interesting because if you go up the food chain just a little bit, you get PHP Crypt, which is a great API for handling legacy passwords, a horrible API for writing new ones. And it's pages of configuration stuff, and it looks like there's only 2 parameters, but in actuality, the second parameter is a magic string you gotta manually create, and it's really complicated. The odds of any developer getting this right is about 0. I mean, I guess it's better than using the wrong cryptographic primitives. It's a step in the right direction. cryptographic MD5, SHA-1, whatever you want to do. The business goal is actually you want to store a password, right? That's what the developer wants to do. That's the business goal. How can I store a password securely? This API, as you dig into it, is very nice. As you upgrade PHP, the internal strength parameters will also get updated. Very hard to go wrong here. Now, is it perfect? Probably not. There's probably lots of stuff here. But this API is what you want for developers to be using. Now, it's interesting, I haven't done this. Domenico's here today. How does PHP's API compare to his best practices? Does your favorite application environment have an equally simple password hashing API? I don't know. Those are areas we can explore and immediately improve the next generation of web apps. The old ones, we have to manually deal with them. But can the next generation of websites just start doing the correct thing? Right now, most languages, there's no chance of that. Some more stuff where we intentionally have made it difficult for developers. Every programming language has some random number generation. And it's sort of a leftover from like the 80s, when it was kind of an interesting computer science problem to figure out how to generate random numbers with nice distribution. We actually know how to do that using cryptographic stuff now. Before that, it was a very interesting science project. Problem is, those are available. I need a random number, I go to the random number thing, which is really designed for physics and math, not security. So there's been any number of password reset codes, auto-generated passwords, just broken because of this type of API. Meanwhile, the actual thing you should be using, totally hidden. And obtuse and hard to get to. Right? PHP provides 2 or 3 different versions of how to do this. And the problem is because they're not random enough, people start doing things like setting the seed, and they've poisoned everything downstream. Right? This actually occurred at Etsy before I started. Someone did like, hey, set seed 1 right before a cookie generation things, before saying it's time to experiment. Like, it's that easy to do. This would be, hey, NSA, here's how to poison all PHP apps. Just inject this one line in, everyone's reset codes are going to be the same. Right? Here's the thing, if you need to do physics, guess what? These fancy math number generators aren't even good enough for you anyway. It doesn't matter, you just don't care. Your needs are now way beyond what's in security languages. So you're going to link in some new stuff anyway, which you do anyway for your app. For toy applications, password reset code, does it matter if it's 50 microseconds and now it's 500 microseconds? No, we really don't care. You just don't have that many needs of it. It's just not really a performance issue. Hey, instead of using the regular one, if you use a secure one, maybe it's going to be a little slower, and it actually turns out to be a performance problem. Hey, you can go write your own. You can actually write the C equivalent random number generator about a line of code. If you need lots of insecure random numbers, go write your own. It's no big deal. Every language makes language trade-offs. Why should this be different? So what if we just swap these two? The default programming language, by default, will give you secure random numbers. When my light settles down, I'll apply a patch, send in a patch to Python, see what happens. It's going to be highly political, but we got to try. We got to try. And what's cool about doing this is the random number problem then turns from a security problem to an optimization problem. And the number of people interested in making things go faster is probably 100x more than making them secure, 1,000x more. Hey, the random number is slow, okay? You're making insecure app, great. That's a problem every computer science student can solve. The security one's harder, so I say make it the default. These are types of things we can do to just proactively prevent problems in the future. And again, instead of making it for the smartest guy, cryptographic primitives, random number generations, we got to be working on how to make it for the dumbest guy. Okay, so C infrastructure. I think I mentioned this already. My hypothesis is high severity CVEs, CERT, are overwhelmingly written in C. I eyeballed the last months worth of stuff, and it was just like, C across the board. Google's just did this third-party bug bounty. Everything they're doing is C-based code. Why? Why are we doing this? C is a beautiful language. The prophets carried it, which he gave us this Bible. Lean, 270 pages, includes the standard library. The downside is how to use it securely, 545 pages. And especially like the 100 pages devoted to arithmetic. Like, there's just no chance you're not going to make a mistake. There's no chance of it. Okay, so I don't know if you know about I'm an author of this library called Good Injection, which my goal is to eliminate SQLite attacks everywhere. It's a ridiculous, impossible goal, but hey, it's a goal. You can go check it out here, goodinjectioncloudline.com. And as I said, it's designed to detect SQL injection, user input, query strings, whatever. I want it to be really fast. I want to have low false positives, because return true is a very easy detector of SQL injection. The hard part is not having false positives. And I want it testable instead of the mess that it is now. But why did I write this in C? Because I'm so good at it? Maybe not. But but why C? Because it's the lowest common denominator. I know if I write it in C, I can plug it into just about every scripting language. I can get it into hardware routers. I can get it into firewall code. I'm able to generate bindings for a few languages. If someone's a good root hacker, they're probably taking all of our time to make bindings for it. If you're that guy, let's talk. You're till Saturday. So really, it's performance and integration with everything. That's why people use C. What if we could do this without C? And can we change, just like the random number thing, can we change a security problem into an optimization problem? Because the number of people interested in speed dwarfs us. And we're beginning to see hints of the future here, where C's advantage in performance is slowly being diminished by just-in-time compilers. There's a whole bunch of interesting stuff. You know about Node.js. Python is a really interesting one, where you actually write a language. It's already been done for Python. You can write a language. It will generate a just-in-time compiler for your language. And it is easily 6 to 7x more efficient than Python, approaching sea level in some areas. Other things, Python.org, you write a restricted sort of Python-esque thing, it will generate C code. Some really interesting stuff here. Not everyone needs, bind in C or your favorite, any C infrastructure you want. Not everyone needs it. Most small businesses don't. Certainly, top 200 websites, emphasis is going to be on performance and speed and scale. A lot don't. Same thing, binding, C binding to scripting languages. Complicated interaction, scripting language to C library. These are also now becoming, you can just actually script C code through scripting languages, no binding needed. You cut and paste your header file, you're able to start scripting C libraries. Really interesting good stuff coming up. There's a lot of room for innovation. And so, in my mind, what is the origin of insecurity? That's the time to talk. Why are we here? And really, the origin of insecurity is us. We know these things. Configuration management is a problem. We know patching and deployment is a problem. We know developers aren't experts in security. We know they make mistakes, and we know C is essential yet really fragile. I'm not really blaming us. I'm saying I don't see much energy devoted to those things. I see a lot in offense. Guess what? I know you can break it. We've made that point. We've pounded. It's like pounding on like skull bits of bones. Like the person's dead. We got it already. You can break things. I got it. The key thing is now, what else can we do? Blocking technologies, certainly essential. Some vendors out there are providing them, certainly essential. But they depend on blocking 100% of the things, right? If that's at 1%, not good enough, right? You're going to get breached. So what I really want is to start seeing some of these problems. I'm not saying the other ones aren't important, but we got to start thinking a little bigger and really going after some of the bigger problems that are really just sort of killing us, to be quite honest. So what can you do? And I'm going to sound like kind of a hippie here. Think globally, act globally, right? Those big problems, you know, it's like, Nick, I'm not going to solve why I see a crappy IMG programming problem. I understand that. I'm not even a developer, you say. Got it. But everyone here, if you're in offense, working with an open source project in the development process is 10 times more powerful than you working remotely just trying to break something. Think big, but then pick a project you can actually help out with. And there's so many of them. You know, whack-a-mole is good. We spend most of our day doing whack-a-mole. That's okay, it's part of the job, I get it. But let's spend a little time thinking big, going after things that are really going to change things. Millions of open source projects out there. Some critical infrastructure, some maybe just for your company. Get involved. Most don't have a security anything, let alone a person involved. This is something where you can make a huge contribution that will eliminate classes of bugs. You might not get the name on the website and know you wrote something, but you're actually building something, which is maybe hopefully more rewarding. If you're not a programmer or security, if you're a security person, fuzzers, getting things compiled with different flags, finding test cases, writing test cases in the development process, super powerful, really powerful stuff. It makes a world of difference. I noticed, I learned this firsthand. I presented Black Hat with injections, like, hey everyone, I got this new thing, it's going to solve SQL injection. Fortunately, the mod security team hooked up with this guy, and he just basically just humiliated me on a daily basis. He's more of an attack person, I'm more of a defense person. Awesome pairing. Like, it's fun and really effective. This guy, like, wildly accelerated everything. He also has a great SQL WTG for those who just want to do that, but great. Right now, certificate transparency, I mentioned. I'm not really involved with it, but what I'm doing is I'm finding certificates that explode their code. Turns out there's no scripting language that can actually parse certificates without a C library. Who knew? Adding test cases, and my favorite, learning how to decode new exotic ISO time formats that some certificates use. It's boring, but it's preventing security problems before the code gets released. So, think big, get involved, bring your friends next time. Business, development, operations, especially welcome. There's stuff they will find interesting, and enjoy the show. Thanks, guys.